designing network access control solutions. Again, high-level discussion. Obviously, there are lots and lots of courses specific to this technology. We could, literally spend a week talking about 802.1x and extensible authentication and TrustSec and all that. Quite frankly, it's not even really covered that much in the CCNP class because it's all part of the CCNP security. But we'll talk about some of these components. From a security landscape perspective, this is really one of the quickest and fastest changing environments in networks today, because we typically deal with, and traditionally network access, and particularly physical network access, was limited to some pretty static configurations, things like port security and putting a user into a VLAN and applying access control lists and so on. But what we'd like to do is we'd like to have the ability to not only apply authentication and access control to the user, but also to the device. So being able to scan a device, identify its profile, do some sort of posture assessment on that device, identify what kind of remediation techniques we need to use to get the device up to the security standards that we've defined in our network. This is all, of course, part of this 802.1x architecture, this extensible authentication architecture. It's an extended version of that, right? Using the identity services engine as our posture node and our profiling node, and using that to apply all of these security principles. But it really extends security end-to-end in the network. And we can even implement things like Cisco TrustSec, MACsec for layer 2 encryption on switch-to-switch links and so on. All right. What is probably one of the biggest things that's changed in networks today that has really driven the need for this network access control concept, specifically 802.1x? BYOD, right? Bring your own device. So allowing users, whether it's in a wired or wireless device, allowing users to bring their own devices, attach those devices to the network, that is going to introduce a whole lot of new concerns about whether or not the devices are secure enough to attach to our enterprise network that was normally in the past very compartmentalized and didn't allow that type of transaction. So the protection that we're going to employ, the goal is to mitigate the possibility of infection or damage or intrusion from viruses or worms or unauthorized access. One of the key components to this protection mechanism is 802.1x. And we use this IEEE function to provide authentication only as the first part, right? To allow devices to attach to the network. So in this lesson, we'll talk about 802.1x based access control. We'll talk about what the authorization options are in 802.1x, a phased deployment approach. We'll look at extensible authentication and what the framework for extensible authentication is. I doubt we'll get into it in as much detail as we certainly could, given that there are, 10 or 15 or 20 different variations of the extensible authentication protocol. But, and then we'll look at native 802.1x supplicants, native to operating systems like Windows and Mac and so on. And then we'll compare that to AnyConnect. And then we'll wrap up this lesson by looking at Cisco TrustSec, okay? IEEE 802.1x is used to provide authentication-based port access control and authorization. In the past, if I wanted to authenticate users to the network, they would connect to the network, they would be placed into a particular VLAN based on my layer 3 control policies, based on port security, whatever it might be. The device is allowed to connect to the network. And then if a user wanted to access resources on the network, we would authenticate the user through a Windows Active Directory session or whatever it might be. Token-based authentication, multi-factor authentication, whatever. The downside to that is we're not doing anything to authenticate the device. We're simply authenticating the user. So 802.1x allows us to extend that authentication principle to not only authenticate the user, but to also authenticate the device. Now, it's not that we have to use both functions, right? We can still simply authenticate a user, but then based on that authentication, that port that the device is connecting to can be placed into a VLAN, it can be placed into a guest VLAN, a remediation VLAN if we need to do some device remediation. And that can all happen dynamically on the back end based on the authorization profile that we get from the authorization server. You can see in the diagram that the authentication server sits on the back end. It's usually a Radius server. In Cisco's world, it's usually ACS, Access Control Server, or it is, which includes Radius, or it's ISE, the Identity Services Engine, which also includes Radius, right? So there are three major components to this 802.1x architecture. We have the supplicant, which is the agent or service that's running on the device that's going to request the access to the network. And then it also responds to requests that it gets from the switch, the attachment point, what we call the network attachment device or network attachment point. We have the authenticator, which is the network attachment device. The network device that the switch connects to, right? LAN switches, wireless LAN controllers, these can all act as authenticators. The device controls the physical access to the network. It doesn't necessarily do the actual authentication, but it proxies those authentication requests by forwarding those requests and forwarding the responses to and from the authentication server, okay? And then we have on the back end the authentication server. This platform does the actual authentication of the client. Now that can be just as simple as what's your username and password, done. Or it could be much more complex, right? What is your username and password? What type of device are you using? What type of antivirus are you using? Do you have the latest antivirus definitions, et cetera, et cetera, et cetera? And that's where ISE comes in. ISE integrates all of those functions into our network. There are two primary methods for authenticating endpoints. One, the most basic, would be just a username and password, okay? And then that would be stored on our authentication server, and we'd have an authorization profile tied to that username. The other would be to use PKI infrastructure, or PKI, I should say, and use digital certificates. All right? In any event, the supplicant itself needs some sort of agent or service that's running on the operating system that supports this 802.1x authentication. Most devices have this supplicant built in natively, the operating system, or you can add a third-party supplicant like AnyConnect, okay, the mobility client from Cisco. If for some reason the supplicant doesn't support 802.1x for whatever reason, it's disabled or it's not configured, we have another solution which is called MAC authentication bypass, or we can use a web portal as well to do web authentication. That's called WebAuth. So there are three primary authentication methods that we see: 802.1x, MAC authentication bypass, or WebAuth, which is using a captive portal and allowing the authentication through the captive portal. Okay. And by the way, I keep plugging this class. It's a great class, CCNP Security. You learn all about this stuff in detail, all right? The Extensible Authentication Protocol, EAP, and there are many, many different versions, LEAP, PEEP, MS-CHAP, PEEP, and gosh, I don't know how many others, is an authentication framework. It's not a specific protocol. It's more of a framework that provides the transport for the authentication parameters that we're going to use in our process. It's always carried by some other protocol. In the case of Ethernet, we use EPOL, Extensible Authentication Protocol over the LAN, EAPOL. And that's what you're seeing here and here, the EPOL messages. These carry the EAP messages on the link between the supplicant and the authenticator. And then on the Radius server, we're using packets that carry the EAP messages between the authenticator and the Radius server, the authentication server. The supplicant or the authenticator can initiate the authentication process. Usually it's going to be the authenticator. In a wireless environment, it might be the supplicant, but usually due to a link detection, we will initiate or initialize that authentication process. The authenticator initiates authentication when the leak state changes. If it goes from down to up, or periodically from time to time, if we're trying to do some sort of re-authentication. What happens then is that the authenticator, the switch, sends this EAP message, an EAP request, or what we call an identity frame, to the client to request the client's identity, right? Username, certificate, whatever it might be. Once we receive that frame, the supplicant responds. Once the supplicant receives that frame, it responds with a response or identity frame. Okay, both of them are identity frames. One just happens to be a request. One just happens to be a response. For some reason, during the boot up process, if the supplicant doesn't receive the EAP request or the identity frame from the authenticator, maybe because of spanning tree, right? Spanning tree by default doesn't have a port fast feature enabled, so the port might not actually be active, even though there's a link detection. So I won't be able to receive the frame. In that case, the supplicant can actually initiate the authentication by sending an EPOL start frame, and that's what's depicted in this diagram. That's going to prompt the authenticator to go ahead and start or kick off this extensible authentication process. Once the supplicant provides its identity, the authenticator begins its role as that middleman or that intermediary device to pass all of the EAP messages and the EAP frames between the supplicant and the authentication server until either authentication is completed successfully or authentication fails. If authentication succeeds, the port gets authorized, and the authorization profile is pushed out by the Radius server to the authenticator, then off to the supplicant. All right? The exact types of messages that are exchanged, the exact frames that are exchanged back and forth, really depends on whatever method we're using for authentication. All right? Now remember, authentication is simply the process of identifying who you are, right? It's not necessarily authorization. So the next step that has to occur is authorization. What VLAN do you belong to? What downloadable ACLs am I going to apply to the interface to protect network traffic flows, and so on? The enterprise campus consists of several different access switches in different buildings in this particular case study. All right, we see that listed there. There's 4 separate access layer switches that go into our aggregation layer and then go into our core layer. Okay? Of course, 802.1x is already implemented at the access layer. We use different port, authentication commands on the ports for that.
Or routers, actually.
I'm sorry?
You can, or routers. Because you can actually, with small offices, you can deploy 801.x on some routers.
Absolutely, absolutely. Yeah. I mean, typically in an enterprise environment, of course, you're going to have all your users connected to switches, but you're absolutely right. This is a feature that's also available on a router platform. Okay. All right. Now, users, of course, belong to a VLAN. And if they move from one building to another building, you're responsible for making sure that their VLAN assignment or membership is correct. Traditionally, it would mean that they'd actually have to plug into the right physical port because the VLANs were statically assigned to the ports and they weren't migratory, right? We didn't have the ability to automatically assign VLANs to ports very easily. Cisco made an attempt at this way back with something called NAC, Network Access Control. Didn't go very well. Very difficult to implement, very complicated. Built on the exact same framework that we see today with 802.1x, but the back end was very, very cumbersome. So ISE obviously fixed, ISE baby, yeah. ISE obviously fixed that problem, okay? We want the ability to have users mobile, right? When I worked at Cisco, if I went to the office, which was very rare, I didn't have an office. I didn't have even a cubicle. I basically just plugged in wherever I wanted to plug in. And based on my 802.1x profile, I would be assigned a particular VLAN and I would be given particular access. This is a very modern way of thinking about connectivity in a network environment, all right? We know that the campus network is always implemented as a 3-layer architecture. The access layer switches, they're going to be layer 2. Our inter-VLAN routing, that's going to be done at our aggregation layers. Users are going to be segmented into different VLANs based on their role in the company, based on what their job is, or the department, or the business unit. We'll have firewall policies implemented in accordance with that VLAN membership, meaning that the VLANs themselves are assigned to a specific IP domain or IP subnet. And then we have firewall rules that are implemented based on those subnets. Now let's assume in this case study that we've already implemented 802.1 access control on all of our access layer switches. All right, when a client successfully gets authenticated, they get assigned to the VLAN that is configured on the specific port, which, by the way, can be pushed down to the port based on their profile. So, but if we don't have that aspect configured, what do we have to do when the user moves from one port to another? We have to manually change the port VLAN membership, and that's not really automated, right? It's not automated at all. It's not very practical. So obviously this is a component of 802.1x and authentication that really helps in this regard. So as the genius network engineer that you are, because this is your case study, you said, you know what, I just learned about, in my thinKtank class, 802.1x. So I'm going to go ahead and implement dynamic VLAN assignments because I already have 802.1x implemented. I already have a radius authentication server. So I'm just going to extend this 802.1x deployment to support authorization, right? Not just authentication and open authorization, but actually user-specific and authentication-specific authorization. That way we can do our dynamic VLAN assignments. By the way, that gets serviced by the radius server. When the radius server, I don't know if it was in the, yeah, right here. This message right here, the access accept message, that's where your authorization comes from the radius server. So I can do my dynamic VLAN assignment in that message from the radius server. With that VLAN assignment, the authentication server can associate a VLAN with a particular user, with a group. It can instruct the switch to dynamically assign that authenticated user to that particular VLAN, which gives us stronger access control. It gives us, well, much more automation. And it doesn't stop there, by the way. right? Because we can do downloadable ACLs, we can apply port security functions. I mean, there's all kinds of things that can be pushed to this port level for security, all right? The dynamic VLAN assignment is the easiest way for us to enforce our segmented endpoints. All of our standards already support this. 802.1x, Radius, not to mention our security principles are based on, at least our network-centric security principles are based on VLAN security. So as long as I can associate a user to a particular VLAN, then I don't have to worry about additional security measures for that user because they're gonna inherit that from their VLAN membership. Very, very cool stuff, right? I lost my train of thought. The VLAN assignment can result in a subnet change. It would typically, unless you're assigning the same VLAN to the client. But really, the client's probably not even aware of that, right? Because they're going to use DHCP, they're going to get an IP address in the appropriate subnet, and they're going to use their communication. But because we're able to dynamically assign this VLAN, we can have our VLAN to VLAN security policy, and so on. Besides assigning the appropriate VLAN for the user, once they've successfully authenticated with the authentication server, we can also use dynamic VLAN assignments to assign VLANs for users that fail authentication, right? Or VLANs that don't fail authentication, but they fail some other enhanced security principle that we've put into place, like device posturing and profiling and assessments. The advantage of using the authentication server to assign VLANs for failed authentication is that it's not an open or a closed door policy. There might be a need for a contractor or whatever to get internet access. So they might fail authentication, but you might put them into a guest VLAN, right? So that they can have limited network access, but they can have open internet access. We might put somebody into a restricted VLAN. All right, we configure a restricted VLAN for users that have a supplicant but fail the authentication process. So maybe that's a user that doesn't have valid credentials on the authentication server. By the way, the restricted VLAN can also be used for device remediation. You need to download this latest antivirus definition. You need to download this latest operating system patch because you're not compliant with our policy. The default VLAN, that's another one that we can assign. That's the VLAN that's configured on the port. So if a client successfully authenticates to the server, but the server doesn't assign a dynamic VLAN to the client, it can just be put into this default VLAN that's retained on the port, kind of like a fallback configuration. Critical VLANs, that's another defined VLAN. That's a VLAN that's applied by the 802.1x enabled interface if the authentication server is unavailable, right? So the client may or may not be able to authenticate. I mean, they won't be able to, but they may have credentials. But for some reason, the authentication server is not responding, all right? We may also want to extend the solution to limit the access for external contractors, guest users, et cetera, all right? So these dynamically assigned access restrictions only allow the access to the resources that the specific person needs, whether it's a contractor, whether it's a hotel guest, whether it's a business partner, whatever it is. All right. All right. Now, if we want to implement a simple solution that's manageable, this is it. Now, it's not 100% simple, right? Actually, the switch port configuration is relatively simple. The back-end configuration, configuring ISE and configuring ACS and setting up the authentication and the authorization policies, that can be a little bit more complicated, which is why we have several classes dedicated just to that. And like I said, it can get even more complicated if we decide to use DACLs, downloadable ACLs. which are access lists that are configured on the radius server that get applied based on user authorization. All right.
We actually, sorry to interrupt, we actually have a huge deployment, like, 8 nodes, and we're basically, not permitted to the network without going through ISE. And just like you said, it's all authorization profiles for contractors, for employees, and it's basically an if and then a statement. If it meets the requirement, then you'll be assigned this authorization profile. So we have wireless, wired, and the firewall part, or any connect part. So it's very huge and kind of, just in line with what you're saying.
Yeah, it can definitely be, and there are a lot of mobile components or a lot of modular components in ISE, and you don't have to implement all of them. You can just say, okay, I want to do basic authentication and authorization. I want to do device posturing. I want to do device assessments, profiling, and posture assessments. I want to do remediation. Those are really the cornerstones to ISE: authentication, authorization, change of authorization as well. If they don't meet a profile and then they meet a profile afterwards. Device profiling: is it a Windows machine? Is it a Linux machine? And so on. Device posturing: if it is a Windows machine, do they have this? Do they have this? Do they have this? Device remediation, and so on. So there's a lot of components, and then you have different nodes in the ISE architecture. He was mentioning an 8-node architecture. That's a very large architecture that supports all of, we're load sharing these functions, and we're splitting these functions across multiple nodes, and to support maybe tens of thousands of different endpoints, right? It can be very simple if you're doing just basic authentication and authorization, downloadable ACLs and VLAN assignments, but it can get really, really complex. Usually most people that tackle an ISE deployment will do it in phases, right? They'll implement some of the basic functions first. Those are verified, and then they start to implement some of the more the enhanced functions and so on. And he's right. It's a GUI-based system with only a few menus. There's only maybe 6 or 7 different main menus that you can access, but it's a layered. There are a lot of dependencies, and it's a layered approach to security. It's a really, really powerful platform. I didn't like it at first. Well, just like anything new, it takes a little bit of getting used to, but it's a really, really powerful platform.
So what we use actually the user authentication. So on your profile, just like what you mentioned with Cisco, whatever you said, to get a VLAN based on your profile. So it just verifies the user. And then, because there's one thing with ISE, the posture assessment, it works, but it doesn't work perfectly with every single environment. So if you do dual authentications, if you do device and user, it will complicate things. So they decided, just to go with the user and the smart card to verify and just get permitted to the network.
Exactly. And it can even get even more complicated, because then you can add TrustSec and MACsec and everything else, security group tags and all that on top of it, which is just another, well, that's a matrix in ISE that, based on security group tags, allows traffic to flow. And so now you can influence traffic flows through your network with this TrustSec environment. So really, really cool product, definitely, and it's actually something that you guys can install on your local machine. It's available as an ISO, and you can put it into a VMware deployment. It's virtualized anyway, and you can have it connect to routers in GNS3 and do a whole bunch of configurations with it. So if you haven't had a chance to play around with ISE, I would definitely recommend it. Okay. We were talking about downloadable ACLs. These downloadable ACLs allow me to enable per user access control lists that are configured on the Radius server. So when a user gets authenticated on the .1x port, the Radius server sends an access control list to the switch, and then the switch applies those attributes to that port during that particular session. Once the session is closed, the switch removes that per user ACL configuration and then puts the port back into an untrusted state. A much more flexible way of blocking traffic, right? Because now, instead of having kind of these global policies that are based on source and destination IP, we can actually have policies based on user authentication, and we can create these policies on the fly. But as we mentioned, and I'll say it one more time before we move on to the next slide, the back end is what gets complicated, and you have to be able to configure that back end to meet the requirements of whatever your particular security posture is going to be. Okay. The 802.1x, right? It can be implemented using a phased deployment model, which is what I kind of mentioned. Although I didn't talk specifically about the different modes, monitor mode, low impact mode, and closed mode. But this is something that I believe is tested on. If it's not on the test now, it will certainly show up on the test at another time. But these are different ways. Well, it goes to what I was just saying a few minutes ago, right? You can break your network if you don't do this correctly. If you're implementing 802.1x and you haven't tested or verified the functionality and gone through and configured your authorization profiles correctly, and you haven't set up the authentication correctly, you can break your network. So 802.1x on Cisco devices, and I imagine this would apply to other devices as well, gives me the ability to implement this in a phased approach. There are three modes of operation. Monitor mode, which by its name you can pretty much guess what it is, right? Monitor mode authentication isn't actually applied. Everybody gets full access. What we're doing in monitor mode is we're just trying to identify if people have the supplicants, if they have the ability to support 802.1x and so on. Go ahead, Dave.
So I apologize, by mistake.
No problem, no problem. Okay. Low impact mode still get open authentication, but we're adding another kind of level of security by having some pre-configured ACL or possibly introducing downloadable ACLs in this case, right? The monitoring mode allows the deployment of the authentication methods, but it doesn't affect the user or the endpoints. We're essentially enabling 802.1x, just opening the door wide open. What that does, though, you might look at that and say, well, what's the point of that? Well, it's a temporary mode. It's not supposed to be a permanent mode. The open access feature allows us to provide unrestricted access for all the traffic, even though authentication is enabled. And then we can verify through this process if the appropriate people have the right supplicants, if the network is ready to support this, and so on. And then we can start to migrate certain ports to different modes for testing purposes and rollout purposes. With low impact mode, we enhance the security by adding some sort of ingress ACL on our .1x enabled ports. And then the ports are configured still in open mode. The ACL controls what traffic is actually allowed for unauthenticated hosts. So we can allow DHCP, we can allow DNS, internet access, and so on, but we can still block access to internal resources. When the port gets authenticated, then we can apply an appropriate authorization. The default mode, though, and this is something you have to be very careful with on a Cisco switch port, is closed mode. The only messages that are allowed to go back and forth on the port are those EPOL messages, the Extensible Authentication Protocol over the LAN, that allows the authentication process to take place. Only once the authentication is completed can you apply the appropriate authorization profile or policy to that particular port. Okay? EAP messages are the foundation or the transport, the carrier pigeon, if you will, of all the messages that get exchanged between the supplicant and the authentication server. EAP messages are directly encapsulated in the LAN protocol, Ethernet 2 in this case, if it's a twisted pair Ethernet connection, between the supplicant and the authenticator using that EAP-hole encapsulation. They get encapsulated on the radius side as well. The only difference is on the radius side, we're encapsulating inside the radius protocol between the authenticator, which is the switch, and the authentication server. The authenticator acts like a proxy, right? I mean, that's by definition what a proxy is, something that does something on behalf of something else. So the proxy between the supplicant and the authentication server, it doesn't actively participate in the communication. It's hard to kind of quantify that, but because it's directly involved in the communication, but it's really just a messenger. It's carrying messages back and forth. It's not making decisions. It's not doing policy enforcement itself. It's simply passing messages back and forth. All right? So it's the decision of the authentication server that gets communicated with radius over to the supplicant. There is two-way authentication available as well between the client and the authentication server. A lot of authentication methods, and there are many, and we're not going to get into all the different EAP methods. Some of them are hybrid, some of them are specific to Cisco, some of them are open standards, but they support different types of credentials. RSA authentication, username and password authentication, and so on. And we can do client-based authentication where we're simply authenticating the client, or we can do mutual authentication where the client authenticates the server and the server authenticates the client. All right, so here's a visual representation of those architectures. And there are two types, right? We have non-tunneled EAP, and then we have tunneled EAP. And you can see kind of what the difference is here, all right? The difference is whether or not we're protecting the client's identity as part of the process. In most modern EAP methods are going to use a tunneled version of EAP so that we have an additional level of protection. In the non-tunneled EAP format, we have a single session that exists between the supplicant and the authentication server. The supplicant sends its identity in clear text to the authentication server. We get our exchange of messages, which then authenticates to the authentication server, and then the user gets its authorization. But nothing is necessarily hidden in this process. Tunneled EAP, on the other hand, and we can see that there are a couple of different ones referenced here, EAP Fast and PEEP. Those obviously are variations of EAP. We're going to take, the inner EAP data is the real data. The outer EAP data is the fake data. It's so if anybody is monitoring that information, they're going to get false or fake information. They're not going to be able to identify the actual user's information. So outer EAP encapsulates that inner EAP function. And it provides the server with authentication, it provides cryptographic functions, and so on. So there are, like I said, lots and lots of different EAP formats. I don't know that we need to really get into the details of all of them. I mean, gosh, if I was to just go through different variations, gosh, there's over 100 different ones, or at least, close to 100 different ones, right? Cisco Leap and Secure EAP and EAP TLS. Even 3Com had their own version of EAP. Microsoft has EAP MS Chat 2, PEEP, just lots and lots of different variations of EAP. Now, that being said, there are some very common ones that are used, right? It's not that you have a whole bunch of choices. Cisco only supports a subset of those protocols. You were going to say something, sir?
Yeah, I was saying I've been through two different deployments, and the PEEP was the most preferred one, and the less problems.
Right, right. Let me talk about some of the, if I can remember all these, gosh, I'm going to really challenge myself here, but let me talk about some of the common ones that you might see. PEEP, for example. PEEP is a tunneled protocol, right? PEEP stands for Protected Extensible Authentication Protocol. It is a tunneled protocol. It uses a challenge response authentication method using public key cryptography. It does server-side authentication, and it sends all of the credentials inside the PEEP tunneled protocol. We would typically use this to tunnel other inner EAP variations, things like EAP MS-CHAP2 or EAP GTC. EAP Fast. EAP Fast is extensible authentication protocol using flexible authentication via secure tunneling. We have EAP Fast 2, which is another enhancement. We've got GTC, which is generic token card. EAP MD5, which uses an MD5 hash. MS-CHAP2, I mentioned briefly, Microsoft Challenge Handshake Authentication Protocol. EAP TLS, using the transport layer security. EAP TTLS, tunneled transport layer security. I mean, there are just tons and tons of different variants of this particular protocol. It's a very difficult thing to keep in line, but let me mention just a couple of more, because these are the ones that you'll see in a Cisco environment quite a bit. EAP Fast, that's tunneled. Those are in fact the only two tunneled EAP methods from Cisco, PEEP and EAP Fast, and that's why they're listed here on this diagram. EAP Fast uses a challenge response, but it uses symmetric cryptography. It doesn't use RSA or public key cryptography, so that's one of the major differences between PEEP. It can use one-time passwords for client authentication, and we can also do server-based authentication, and it supports plain passwords, etc. EAP GTC, this is non-tunneled. It doesn't do a challenge response. It does clear text transfer of passwords. And it's used usually for one-time password environments. EAP TLS, also a non-tunneled version. EAP TTLS would be a tunneled version of that, but it uses a challenge response. Because it's based on TLS, it's going to use RSA, of course. So it uses certificates for client authentication and server authentication. But in order to use ETLS, you have to have client-side certificates. So that's a bit of a challenge. MS-CHAP2, V2, and MD5, both challenge response methods, both non-tunneled. Both use passwords to do the client authentication, but there is no server authentication with MD5. We do have server-side authentication with MS-CHAP V2. Of course, MS-CHAP V2, being that it's a Microsoft variant, is probably going to be used in Active Directory domains and Active Directory environments. And EAP MD5, highly susceptible to man-in-the-middle attacks, never use it, right? So that one you can kind of forget about. So again, it's a lot of information. And it's the one thing that all my CCNP security guys pull their hair out on every time we talk about it, because it's just really, really confusing, all these different variants and trying to keep them in line and so on. All right. In end result, right? Regardless of the variant that we're using, regardless of what it supports or what it doesn't support, the whole point is user or machine authentication. All right. Traditional machine and user authentication work by treating the machine and the user as two physical separate entities, right? We would use static methods to authenticate the machine, MAC address filtering, etc. And then user authentication would be performed when the user logs in. All right. And then when the user logs off, machine authentication gets performed, right? All common supplicants like AnyConnect, the Windows native supplicant, support both of these authentication options. A more advanced method is to use something called EAP chaining, which supports both machine and user authentication inside of a single outer TLS tunnel. So it combines these functions. It allows you to combine the results, of the machine authentication and the user authentication into a single authentication result. All right, that's going to allow you to assign privileges to users who connect to the network using corporate managed computers a different way as if they were connecting to the network using a BYOD computer, right? All right. And EAP chaining, again, way beyond the scope of what we're talking about in this class, but it was introduced in, I'm trying to remember which variant it was for. Oh, it says on the slide there, sorry. EAP Fast version 2, all right? And by the way, that's a Cisco proprietary solution. That's not something that you would see in the network. IETF is actually trying to come up with their own which is called TEAP, I think it is, Tunnel Extensible Authentication, something like that. I think it's TEAP, don't quote me on that. But it's not a standard yet. So, well, it wasn't at the time this was published. I haven't looked it up since then, but anyway, okay? So you can see that, these principles that we're talking about, these are great principles to understand, but by a long stretch, we're way far away from actually looking at these in depth. So that's the only downside, of course, to this particular class. What does Cisco offer as a supplicant? Well, it offers the AnyConnect Secure Mobility Client. It includes modules for VPN, traditional VPNs, IPsec VPNs, as well as SSL VPNs, network access, web security, Wi-Fi access, a whole bunch of different kinds of things. It is literally a network access manager. It allows me to manage every aspect of connecting to a network. And when you actually download and install the client, you can choose which modules you want to include in the deployment. Most use it for wireless access, or they'll use it for VPN access, but it does a lot of other things, including 802.1x. The Network Access Manager, which is built into, which is part of the AnyConnect client, supports PEAP, EAP TLS, MS-CHAP2, EAP GTC, EAP Fast, including EAP TLC, MS-CHAP2, GTC, and then it supports EAP TTLS, which is the tunneled TLS option. So that will support PAP and CHAP and MS-CHAP and MD5, a whole bunch of different inter-tunneling methods that get carried over EAP TTLS. All right. We can use the native supplicant on Windows, but you're not going to get all of those connection options that you would get with the AnyConnect client. All right. The last thing that we'll talk about in this chapter, or in this lesson, is Cisco TrustSec. Again, another topic we could spend hours and hours, probably days, talking about. I mean, it's not really complex. I mean, it's not extremely complex, but it's certainly more complex than just a single slide. The point of TrustSec, and obviously being that it's Cisco product, Cisco TrustSec, it is proprietary to Cisco's environment, is it is intended to simplify the provisioning and management of secure access to network services, and even more specifically, applications on the network. All right? Most network access restrictions are based on network topology. What's the source address? What's the destination IP address? What are the port numbers? What are the protocols that we're running? But Cisco TrustSec allows you to define policies using logical policy groupings. So we can maintain access even if the resource moves to another part of the network. It doesn't have to be a static configuration. All right, it is a dynamic configuration, very much like we have with ISE and the ability to control network access through ISE. The way it does it is TrustSec classifies traffic based on the contextual identity of the endpoint, not based on its IP address, which is what we typically do in most security environments. All right, so we create this thing called the security group tag, and we assign that security group tag to the endpoint, which is done through ISE based on authentication and profiles and everything else. That tag identifies the endpoint in the network. Regardless of wherever that endpoint goes, it has this tag. And based on that tag, we can then allow traffic to flow or not flow based on policies. So it doesn't matter where you're attached to the network, wirelessly, wiredly, I guess, if that's not a word, but this security group tag identifies the endpoint. And if we have TrustSec aware devices like switches, routers, and firewalls, we can make forwarding decisions based on this matrix in ISE that identifies what tags can talk to other tags. Think of it almost like a zone, but it's more specific than a zone, right? Because it's tied to an individual entity. All right? The features that get associated to a security group tag on the network are classification features, transport features, and policy enforcement features. Those are the three major components. And we see that listed here. Oops, sorry about that. We see that listed here, classification, transport, and enforcement. All right? Classification is the actual assignment of the SGT to a particular endpoint. That can be done dynamically, or it can actually be done statically. Typically, it's done dynamically, and dynamic classification is performed at the access layer using some sort of 802.1x component, ding, 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 and ISE, right? So the security group tag gets assigned through the authorization of the endpoint. ISE does that. It authenticates the user based on the profile, based on its posture. It'll assign a security group tag to that endpoint. Static classification, not really done that often. We will see it, at least not for the end users, right? We typically see static classification done in a data center where we have servers attached, right? And servers aren't very mobile. They're not going to be moving around the network, so static classification works a little bit better in those types of environments. And it's basically just the mapping of an IP address, a VLAN, a port, and the SGT itself. The security group mappings follow the traffic through the network. It's embedded in the data that's being created by that endpoint. And that's done through inline tagging or by using another protocol called SXP. SXP is the Security Group Tag Exchange Protocol, which is part of the TrustSec architecture. And that's going to allow us to, and all of the TrustSec aware devices understand that protocol. If I'm using inline tagging, the actual tag itself gets embedded inside of the Ethernet frame header. Now, not every device is going to support inline tagging. So for the devices that don't support inline tagging, we can use SXP to support this mapping across that device. All right? So that's our transport. Then the enforcement gets implemented with basic policies, access policies, permit or deny access policies. Anybody in Baltimore right now? They just had an earthquake there. Interesting. 5.1. We can implement permit policies, deny policies based on the source and the destination, not packet, like we would normally do in a network-centric architecture, but based on the security group tag. All right? And we use these things called SGACLs, security group access control lists, that allow us to identify that component, and SGFW as well, security group firewalling. All right. Cisco TrustSec, as I already said, that's a Cisco-specific solution, and ISE is a huge component of that. In fact, ISE is part of what we call the Cisco Borderless Network, right? The company's TrustSec product, right? It's a product that enables all of these things that we just talked about, okay? And really has become the cornerstone to almost all of Cisco's security deployments, okay? So that is it for that chapter. We talked about 802.1x, what it provides, authentication-based port access control and authorization. We talked about a little bit about the Extensible authentication protocol. We talked about downloadable ACLs and dynamic VLAN assignments through our authorization profiles. How we should use a phased deployment mode to limit the impact of our lack of understanding and lack of knowledge about how to implement 802.1x initially, so we don't break our network. We talked about the use of AnyConnect and how we can use that as our supplicant. And then we wrapped up the chapter by talking about TrustSec and enforcement policies based on contextual identity of the endpoint rather than some sort of physical identity through its IP address and whatnot. All right, so that concludes that lesson, and that pretty much concludes that module as well.